Right, so when you're looking at B, which is this one here, when you redraw that to do your Norton current, you would draw something like that. What you should notice when you draw something like that is that you've now got a short circuit across that R4, effectively meaning that R4 isn't really there. If you put a short circuit across the resistor, no current's going to choose to go through the resistor, is it? It'll all go through that short circuit. So your circuit very quickly goes from being that to being more like that. So no current's going to choose to go through the R4, so you can disregard the R4 and just keep your R1, your R2, and your R3. When you do that, that circuit then becomes very similar to the one that you've just done. Okay? So then you should go from this circuit here to this equivalent circuit here. Then from this, you've got these two resistors in parallel, R2 and R3, which are these two resistors over here. So your current leaves your supply, goes through the 5 ohm, hits that junction there, which is the same as that junction there, splits, rejoins at this junction and goes back to the supply. That's this junction here. So these two are in parallel, which is those. 10 to 5 in parallel gets you 3.33 ohms. Then your total, you're going to add that onto the 5, gets you 8.33 ohms. Then to get your supply current, you do Vs over RT, so 12 divided by that 8.33. It actually makes more sense. It'd be about 1.44. I don't know where I've got that from. Oh, I know what I've done. Yeah. 1.44. And then you're going to do a current divider on the 1.44. So it's going to be 1.44 times that R2, which is in the opposite branch, 10, divided by these two branches added together, 10 plus 5 is 15. Gets you 0.96 amps. And that's your Norton current. So once you've done that, you go on and you do your Norton resistance, which is the same as you did your Thevenin resistance. But this 10 ohms doesn't disappear anymore. It's back in. This is a whole separate job. So once you've done your Norton current, you're going to put that to one side. Go, right, that's my Norton current. I've got that. That's it there. That's what I need to know from that page. You go back and look at your original circuit again. Short out the supply this time. And draw out your circuit. And again, you're kind of pretending that your supply is now over here. And you're working out the resistance from this perspective. So your R4's there. So you try to redraw that first. The R4's in this circuit. You've got to think your Norton current is a separate job from your Norton resistance. So once you've got your Norton current, Put that to one side, go back and look at your original circuit and think to yourself, how am I going to get my Norton resistance? So this would be the circuit you would draw for this. And you'll be able to redraw this into a series parallel network that kind of looks like that. And you're trying to reduce that to one equivalent resistance. Okay? So once you've drawn this, you're going to go through the process of doing an RP for down here, 5 in parallel with 10 gets you 3.33. Then that in series with your R3 gets you 8.33. And then your 8.33 in parallel with your 10 should get you a Norton resistance of 4.54 ohms. Yes. Then from that, so this is our second thing we need. So we've got our Norton current from here. We've got our Norton resistance from there. And you're going to draw your Norton equivalent circuit. So that'll be your Rn, that 4.54 you've just worked out. Your RL will be back in your original circuit diagram, 4 ohms. So from that, you're going to do a current divider to get the current through the load, and then you're just going to do V equals IL. And when you do your current divider and then your voltage divider, those are the answers you should get.